Hello, universe. Today I wanted to recommend you this textbook called Differential Equations and Boundary Value Problems, Computing and Modeling by Edwards, Penny, and Calvis. Okay? So here's the textbook. This edition that I have is the 5th edition. I took this course in differential equations as an undergraduate at the University of Utah, and this is an undergraduate level textbook. Okay, so the prerequisites that you need for this textbook are just calculus. If you're taking calculus 1, 2, and hopefully calculus 3, then you're ready to tackle this textbook. This is going to be the key prerequisite after calculus that you need before you start studying partial differential equations. So I had a viewer ask me what prerequisites they need given a calculus background in order to study partial differential equations, perhaps by this book that I recommended by Haberman in my previous video. And the answer is that in order to study partial differential equations with a calculus background, the only prerequisite that you need is differential equations, or at least this is going to be the main prerequisite. You might want to know a little bit of linear algebra, but you don't need it as much. So let's just look at the table of contents here, and I'm going to recommend, I really like this textbook because I'm familiar with it. I've read a lot of this textbook. I took a course on this textbook and solved a lot of exercises from it here. I think the exercises are great. They're a great introductory level exercises. And overall, I think that there are solutions in the back of the book. We can check, but I'm pretty sure, yeah, there are solutions in the back of the book. So that's always helpful. And yeah, this is a great textbook. I self-studied a lot of the course from this textbook, so it's good for self-study. Now, chapter 1 is on first-order differential equations. This is going to be a critical chapter, kind of getting to know the basics of what a differential equation even is. It's essentially an equation involving the derivatives of some unknown function, okay? And then chapter 2 is going to tell you a little bit about some examples of some first-order differential equations. So they're going to introduce a population model here and acceleration velocity models. These are some classical models that just arise from simple first-order differential equations. And then they're going to finish off this chapter with a little bit of numerical approaches. So these numerical approaches, what that means is they're essentially ways of approximating the solution to a differential equation using some sort of algorithm that can be run on a computer, okay? So chapter 2 is going to be an important introduction to numerical methods, which is going to allow you to code or implement solutions to real problems on the computer, right? That's the computing part of this textbook here. Now, chapter 3 is going to be linear equations of higher order. This is, again, very important. The idea is that now we're going to introduce more than one derivative. So maybe I have an equation involving the second derivative or even the third derivative, etc. So I have linear equations of higher order. There are some important models that show up, namely this oscillator. Okay, so the harmonic oscillator model is a linear equation of higher order. Okay. And also some important electrical circuits equations can be, in their simplest form, linear equations of higher order, okay? Now chapter 4 is going to start giving you an introduction to systems of differential equations. This is important. Oftentimes you want to reduce higher order differential equations into systems of lower order differential equations. And you'll see that done in this textbook quite frequently, especially in chapter 5. So chapter 4 is just an introduction to what it means to have a system of differential equations. This just means you have more than one equation, essentially, and they're usually coupled in some way. And then chapter 5, again, is going to be a really important chapter about linear systems of differential equations, okay? And so you're going to have to know a little bit about matrices and linear algebra, and I believe that is introduced in this chapter. Okay, so you can see that starting here, they start with matrices and linear systems, and so you're going to have to know how to find eigenvalues of matrices. Okay, this is something that you're going to learn much more in detail in a linear algebra course, but you don't need a full course in linear algebra in order to study chapter 5. Okay, you might have to Google, and it might be a little bit difficult, but I think you can just learn chapter 5 with just a calculus background, to be honest. You're going to have to figure out, I think they introduce, let's just check real quick because I don't want to give you bad advice, but yeah, it's certainly going to be helpful to have a background in linear algebra, but I don't think it'll be necessary. Yeah, so Yeah, they do some review of matrices here, okay? So yeah, they're gonna set you up where you're gonna be okay. Yeah, you're gonna be okay if you don't have a linear algebra background, okay? So that's good. So yeah, you can just go straight into this with just a calculus background. And all the way up to chapter 5, this is essentially a full undergraduate course in differential equations. So chapters 1 through 5 are going to be the most important prerequisite chapters so that you can get to studying partial differential equations by Haberman. Okay, so those are going to be the 5 chapters you're going to want to cover. And then in an undergraduate class, you would choose at the end of the semester to either cover chapter 6 or chapter 7. And in our class, we chose to cover chapter 6. I would probably recommend chapter 7. It's on Laplace transforms. Chapter 6 is also very important, and it's about approximating nonlinear systems with linear systems. And both of these chapters are going to be really important, but I would say that they're not like a necessary prerequisite for reading a book on PDE. And then chapter 8 is power series methods. This is super important as well. Okay, so chapters 6, 7, 8 are all really important. Power series methods get used a lot in partial differential equations, or just in solving some of the differential equations that arise in partial differential equations after separation of variables. But this is usually explained in a partial differential equations textbook. So it's good to have this resource, but it's probably going to be explained to you in the partial differential equations course or textbook when you meet it. So they're not going to assume this is a prerequisite. And then chapter 9 is already jumping into partial differential equations from the approach of the Fourier series, which is really important. So if you want kind of a first glance at partial differential equations, you can even read to chapter 9 and 10, because chapter 9 and 10 is eigenvalue methods and boundary value problems. 9 is Fourier series methods and partial differential equations. These chapters are already a sneak peek at what you're going to be learning in a partial differential equations course. So you can see it just transitions nicely at the end of the book into partial differential equations. So the natural follow. So basically what you need to study this book is calculus, and then it's helpful if you have a little bit of knowledge of matrices and linear algebra, but it's not required. What's required is a calculus background. Then you can study this book and then move on. Once you finish chapters 1, 2, 3, 4, and 5, you can move on from this book to the book by Haberman on partial differential equations and begin studying this material, okay? So I hope that was helpful, and yeah, I wish you luck in your studies.